Okay, so now we'll move on to the next section of the lesson, tangents and normals to a hyperbola. Okay, so in the previous part, we were discussing about what tangents and normal to the ellipse, right? So now we are going to discuss about the tangents and normal to the hyperbola. So once again, we will do both the proofs. So the first proof that we will do is we will find the equation of the tangent to the hyperbola. So let's write down the equation of the tangent to the hyperbola with the equation x square over a square minus y square over b square equal 1 at the point p is a cos t, b sin t is equal to this equation. Okay, so let's get started with this one. Actually, you can see they have given you two equations for the tangent. Do you see? Because if you remember in the hyperbola, do you remember that there were two parametric equations given? A cos t, b sin t, and there was another name of a sec t tan, b tan t. If you remember in the hyperbola equation, I gave it, we did two sets of parametric equations. Okay, so for both the sets, there are two proofs. Okay, so shall we start doing the two proofs quickly? Let's get it done fast. Okay, let's start with the first proof. The equation of the, so I'm going to start with this proof first. Okay, let's try to get this equation. The equation of the ellipse is x square over a square minus y square over b square equals 1. So you know what's the first thing we should do to get the equation of the tangent? We must first differentiate. Let's differentiate the equation. So I'll keep the 1 over a square aside. X square differentiation is 2x. I'm differentiating with respect to x. Okay. Here minus 1 over b square stays, while y square differentiates to give you 2y to the power 1. After you're done with the y differentiation, you must differentiate inside y with respect to x, which gives us dy by dx. Do you agree? Equals to differentiation of 1 is 0. Okay, so now let's make dy by dx a subject. I end up getting here minus 2y over b square dy by dx. Okay, that's what I have over here. 2x over a square is what I have over here. I think the best thing is I'll take this term to the other side, the negative term to the other side. That would be the best, right? So I end up getting 2x over a square remaining in here. Minus 2y over b square becomes plus 2y over b square dy by dx. Okay. So making dy by dx a subject, you can see the 2 will cancel out. So I end up getting here the b square comes on top over a square, and you have x over y equals dy by dx. So this is the gradient of the tangent. Do you agree with me? Dy by dx. Let me write it to the correct side. Dy by dx equals b square over a square x over y. Okay, so now let's substitute the coordinates. What are our coordinates? P is a cos t, b sin t. Okay, let's substitute the values and get the proper gradient of tangent. So dy by dx of the tangent. So dy by dx of tangent is, what is it? B square over a square. What's our x value? X is a cos t and y is b sin t. Okay, so this is the gradient of the tangent basically. Okay, so now it's time to find the equation of tangent. So equation of tangent. So what is the equation of tangent? We'll use the equation of y minus y1 equal gradient x minus x1. Y minus the y1 equation. Y1 is b sin t. Gradient is b. I think I can simplify here, right? Yeah, I can cancel off a and a b, so I end up remaining a b over a because the a to a cancels and the b to b cancels. So I end up getting b cos t over a sin t. Okay, so this is b cos t over a sin t. Okay, in times x minus x1 is, it was x1, a cos t. Okay, so now I need to get the show that, okay, the show that has ay sin t, okay, bx cos t. What I'll do is I'll take the a sin t to the other side as a multiplication. Is it okay if I immediately multiply? Will you be able to realize? Because we can save a step, right? So I prefer to save one step quickly. So y times a shine t is ay shine t. Okay, I saved one step. B shine t into a shine t is ab shine square t. So even here I'm going to save one step by immediately opening the bracket with b cos t. Is that okay? In the earlier process, in the earlier section, I was doing this separately. Now remember, I did this, I wrote the whole thing again, but now I want to reduce one step. So this is b cos t into x is bx cos t. B cos t into minus a cos t is minus ab cos square t. In the show that they have ay shine t in one side, bx cos t in the other side. Can you see? Ay shine t is in this side, bx cos t is in the other side. So I think we already have it like that, right? Ay shine t here, bx cos t is in the other side. So that looks okay. The thing is they have got a ab here. Okay, so let's get the ab here. So I get here ay shine t, let it be over here. Okay, because it's in the perfect position. What I'll do is I'll take the minus ab cos square t to the other side. Is that okay? Minus ab cos square t comes as plus ab cos square t to this side. Are you okay with that? And then minus ab sine square t remains equals bx cos t. Okay, so now I'll take the ab out. From these two terms, I get cos square t minus sine square t equals bx cos t. So cos square minus sine square, this is the first, in the first lesson we learned, cos square minus sine square is 1. Okay, cos square minus sine square is 1. This is the hyperbolic identity, right? So then ay sine t plus ab equals to bx cos t, which is the show that. Okay. Then before I go to the equation of the tangent with this, with the other parametric one, what I'll do is I'll go for the equation of the normal with this same coordinate, yeah, with this same ellipse and the point. Okay, so I think that is given on the other side. Can you see it? An equation of the tangent, an equation of the normal to the hyperbola with the equation x square over a square minus y square over b square equal 1 at the point p a cos t b sin t is this. Do you see this? This is for that exact same point, but now it's the equation of what? The normal. Can all of you see that? So I'll take it to the other side and let's do this proof again. For the exact same ellipse, for the exact same point, let's get the equation of the normal now. So then an equation, now we are going to do the same for the same point, and for the ellipse we are going to get the equation of the normal. So I think you can see I can omit the first part of my version because I have already got the dy by dx of the tangent. Can you see? I already have the dy by dx of tangent in this particular part. Do you agree with me? Dy by dx of tangent, what was it that we found previously? B cos t over a sin t. Do you agree with me? So then what will be the dy by dx or the gradient for the normal? Reciprocal and change the sign. So this is minus, I get a sin t over p cos t. Right, then let's get the equation of normal. Equation of normal, y minus y1 equal gradient x minus x1. So y minus y1 is, the point is the same, right? B sin t. Gradient is minus a sin t over b cos t. X minus x1 is, what is x1? X1 is a cos t. So we'll bring the b cos t to the other side. Y minus b sin t times b cos t minus a sin t times x minus a cos t. Is okay? Then y into b, I get by cos t, right? Minus b square Sine t cos t, am I correct?
Yes.
Here I get minus a sine t into x is minus ax sine t. The other one minus a into minus is plus a square sine t cos t. Yes, I can skip this step. Yes, I could have written this immediately. Then in the show that the ax sine t by cos t are on the same side, right? So basically it means the minus ax sine t should be brought here and this should be brought there. Do you agree with me? So when I bring it here, I end up getting plus ax sine t plus by cos t. Do you understand? Equals on the other side I have a square sine t cos t plus b square sine t cos t. So I think you can see I can take sine t cos t out and I end up remaining with a square plus b square equal x sine t plus by cos t. So this is the answer. Okay, so this is when I work with the point, the ellipse and the point a cos t, b sine t. Okay, so this is the entire section of proof. So now what we need to do is in the next part, we need to do the whole, the entire proof for what? The equation of the tangent and normal for the hyperbola with the point 1. With this trigonometric partition, with the trigonometric point. A sec t b tan t, because earlier one was a hyperbolic point, right? Did you notice? So now with this one. So the whole process has to be repeated again now. So let's start. If I'm doing this, then equation of the tangent to the hyperbola with equation x square over a square minus y square over b square equal 1 at the point. What is the point now? A sec theta, b tan theta. Let's get started and let's try to get the show that. I'm working on this show that now. Okay. So I get here x square over a square minus y square over b square equal 1. Because it's a new coordinate, I'll do it, derive it again from the beginning. Okay, because it's a new point. So what do I get when I differentiate? 1 over a square, x square differentiation is 2x. So then minus 1 over b square into y square differentiation with respect to x plus priority for the power 2y to the power 1. After you're done with the power, go inside, differentiate y, we get dy by dx equals 1. So basically I get 2x over a square equals 2y over b square times dy by dx. Do you agree with me? 2 to 2 cancels. And then I get here dy by dx equals b square over a square x over y, right? B square over a square x over y. Do you agree with me? So then I want to get the gradient of the tangent at the point P. P is a sec theta and b tan theta. Do you agree? That's the xy. So let's get dy by dx. Dy by dx equals so dy by dx of tangent. Okay. B square over a square, x is a sec theta and y is b tan theta. Are you following me? So you can cancel off a to a and a b to b, right? A to a and a b to b can be removed out, and I end up getting here b sec theta over a tan theta. Is that correct? B sec theta over a tan theta. So then now let's go for the equation of tangent. Y minus y1 equal gradient x minus x1. Y minus y1 is b tan theta, gradient m is b sec theta over a tan theta. X minus x1 is a sec theta, right? So then I'm going to take the a tan theta and shall I do it in one step where the a tan theta multiplies with the whole side. A tan theta into y is ay tan theta. Do you agree? AB tan into tan is tan square theta. This is bx sec theta minus AB sec square theta. So when I look at the show that the bx sec theta minus ay tan theta, can you see? Bx sec theta is positive, ay tan theta is negative, which means according to what I got, bx sec theta is positive here. I should take the ay tan theta to the other side. And this unwanted term, I'll take it here. So minus ab sec theta comes here as, do you see what I'm doing? Minus ab sec theta comes here as plus ab sec square theta. This side you are remaining with minus ab tan square theta. The other side we have Vx sec theta who is coming here. The positive ay tan theta comes as negative ay tan theta, which is exactly how we wanted in the show that. Now I'll take the AB out from this side. When I take AB out, I end up getting sec square theta minus tan square theta equals Bx sec theta minus ay tan theta. So then the P3 formula you learned is what? 1 plus tan square theta is equal to sec square, which means sec square theta minus tan square theta gives you what? Gives you 1. So basically this guy is 1. So this is AB equals Bx sec theta minus ay tan theta, which is exactly what we wanted, which is our show that. Okay, so this is the equation of the tangent. So now what I'm going to do is I'm going to do what? With the a sec theta b tan theta point, I'm going to get the equation of the normal to the hyperbola. Shall we continue? So then y'all know when I go to get the equation of the normal. Okay, so I'm now going to calculate the get the equation of normal. So what is the thing that remains the same? I don't need to differentiate from the beginning because I already have the dy by dx of tangent. But the point is also the same, right? We are using the same point. So let's start with the dy by dx of tangent. What was the dy by dx of tangent? The dy by dx of tangent was, so I have it here on top, b sec theta over a tan theta. Check b sec is b sec theta over a tan theta. So now I want the dy by dx of the normal. What happens when you take normal? Reciprocal and change the sign. So minus, and I get a tan theta over b sec theta. Is that okay? And then let's get the equation y minus y1 equals gradient x minus x1. So y minus y1 is b tan theta, gradient m is minus a tan theta over and then x minus x1 is a sec theta. Okay, and then take the b sec theta to the other side. Shall I immediately multiply? Y into b sec theta is by sec theta. Then b tan theta into b sec theta is minus b square tan theta sec theta equals here minus a tan theta into x is minus ax tan theta minus a tan theta into minus a sec theta is plus a square tan theta sec theta. Is that okay? Okay, then we need to get the show that has what? Ax sine theta plus a square. Okay, by plus ax sine theta equal a square plus b square tan theta. Okay, no, I can see it. Yeah. Okay, this is what I need to get. This is my show that. Okay, so I can see now there is no by sec. Now I have by sec theta. They don't have a by sec theta. Do you see? So yeah, what we could do is to get rid of the sec, sec is actually what? 1 over cos. Sec is 1 over cos. Shall I multiply the whole equation with the cos? Because you understand that when a sec theta multiplies with a cos theta, what happens? It cancels out and becomes 1. Sec is 1 over cos. 1 over cos into cos is 1. Okay. So by sec theta, when I multiply with the cos theta, sec into cos is by. So just by because sec and cos will cancel. Here also minus b square tan theta. The sec and cos will cancel. Do you agree? They all become free. This one becomes minus ax tan theta will multiply with the cos theta. Do you agree? The last one plus a square tan theta, that guy also becomes free because the second cos multiplies to give you 1. Do you understand? Multiplying by cos removes sec in so many places. Sec is now in 3 places. All of them are removed just because you multiplied by the cos. Okay, so now it's a matter of rearranging. Okay, so in the show that equation, it's by alone. Ax sine theta they have taken to this side. So this is ax tan theta cos theta. Let me take it to this side. And I'll take the b square to the other side. What do I get here? By plus ax tan theta cos theta equal a square tan theta minus b square tan theta goes to the other side as plus b square tan theta. Are you with me? So then now you can see I didn't get the immediately the show that because the show that has ax sine theta while I have ax tan theta cos theta. So what do you do here? Tan theta is sine over cos. Tan theta is sine over cos. Do you see how simple this is? Taking the tan theta out. The cos to cos cancels. And you get by plus ax sine theta equals, this is what we need, right? A square plus b square times. Okay, so this is the show that. So we did all the 4 proofs for both the sets of parametric points. Okay, so this is the equation of the normal and the equation of normal and the tangent. So all of them are done. Okay. Okay, so now since we are done with the proofs for the equations of the normal and tangent, now we will once again go for the condition needed for the line y equal mx plus c needs to satisfy in order to be a tangent to the hyperbola. Okay, so then they have given you the condition is b square plus c square equal a square m square. Okay, so in the earlier section also we did a proof similar to this. In the ellipse it was b square plus a square m square equals c square, right? So then they say here, this is a general result about tangents to hyperbolas. Unless you are asked to prove it, you could quote it in your exam. Okay, so unless they have asked you to prove, you could use it. Okay. Okay. Then let's get it done. The equation of the line is y equal mx plus c, and the hyperbola equation is x square over a square minus hyperbola is minus y square over b square equals 1. So once again, what do? We attempt to solve the two equations simultaneously. So x square over a square minus y is mx plus c square over b square equal 1. Okay, so now what I'll do is I'll multiply the whole equation with a square b square. What do I get here? A square will cancel. I get b square x square minus a square times mx plus c square equal a square b square. Are you with me? Right. So now let's open the bracket. B square x square minus a square times mx plus c whole thing square is m square x square plus 2mxc plus c square. I open the power. Okay, the mx plus c square a square b square. Okay, now let's open the whole thing and separate. Okay, separate the x square terms, x terms and the constant terms, making this into a what equation? Making this into a quadratic equation because A, B, C, and M are all constants. Okay. So the only variable here is x. So when I separate this out, I get b square x square minus a square m square x square. Okay, you agree with me, right? Minus 2a square mcx. I put the x to the corner so I can easily identify. Minus c square a square equal a square b square. Are you with me? So now what I'll do is I'll separate the terms, the x square terms in one side. So this is x square. This is the x term. Let me bring the x square out. I end up getting here b square minus a square m square minus 2a square mcx. I'll take these two guys here minus c square a square minus a square b square equals 0. Do you agree with me? This is okay? Okay, why shall I simplify this a little bit more because it will be easier to input into our equation from the last guy. Yeah, taking an a square out, then I get here c square plus b square. When I take the a square out, it's easier to simplify. So basically, this is the quadratic equation. This whole thing is my a. This is the b, and this is the c. So this is ax square bx plus c equals 0. Do you see? So in order for the line to be a tangent, what is the rule? In order for the line to be the tangent, this particular quadratic equation gives the solutions where the line and the tangent, where the curve and the tangent meets, right? So this quadratic equation should give me how many solutions? Only one, because there's only one cutting point. So there is one root. There is only one root, which means what? Which means the discriminant b square minus 4ac will be equal to 0. So b square. B is, now remember here, b is minus 2a square mc, okay, not just. So minus 2a square mc b square minus 4 times a is b square minus a square m square times c is minus a square times c square plus b square. Do you agree with my working? Yeah, when I open the bracket, minus when you square, it's a positive. So 4a to the power 4 m square c square minus is plus, right? In here, because this is one term, this whole thing all are multiplications, right? So when you multiply 4 with minus, it becomes a positive. So plus 4, shall I take the a square front? I get b square minus a square m square times c square plus b square equals to 0. Okay, so now what we do is take the whole equation and divide. Now there are only two terms, right? There are, even though this looks so big, there are only two terms. I took the minus a square with the minus 4 and it became plus because these are all multiplications. Okay, so then I counted this point and there are only two terms now. Do you see? This is one term, this whole thing is one term. Now that's a common thing to both of them. I can divide both of them by 4 and a square. So when I divide with 4a square, what's remaining? A square, m square, c square. Here 4a square is gone. So I just remain with b square minus a square m square times c square plus b square equals to 0. Okay, so now open the bracket, a square m square c square plus, yeah, open the bracket, b square c square plus b to the power 4 minus a square m square c square minus a square m square b square equals to 0. So again, there are like terms. These two guys, a square m square c square, will cancel out. Yeah, from the remaining terms, b square c square plus b to the power 4 minus a square m square b square equals 0. I can divide the whole thing by b square. Everyone, b square is common to everyone. So I end up getting c square plus b square minus a square m square equals 0. So this is actually to show that, right? b square plus c square equal a square m square. Isn't this to show that? So if the line y equal mx plus c is a tangent to the ellipse, then it must satisfy the condition b square plus c square equal a square m square. Okay, so this is a similar proof that we did similarly for ellipses as well. Okay. So let's go to exercise 2A, question number 1. Find the equations of the tangents and normals to the hyperbolas with the following equations at the points indicated. Okay, so I'm going to do part A. So they wanted to find both the tangent and the normal. Okay, so then you can see this is the point is given as 12,4. So we will have to do it from the beginning because it's not a hyperbolic or trigonometric point. Okay, so basically you have to differentiate and do the whole thing again. So basically we have first one part A, x square over 16 minus y square over 2 equals 1. First thing is what you differentiate with this with respect to x. 1 over 16 stays, x square differentiation is 2x. 1 over 2 stays, y square differentiation is 2y to the power 1. Y differentiation is dy over dx equals to 0. So here, of course, the half and 2 can cancel. This is 2 and this is, so this one I get x over 8 remaining here on the other side. I'll take this to the other side. I get here y times dy by dx. So it's negative, so it goes to the other side as positive. When I make dy by dx a subject, I get x over 8y. Do you agree? It's x over 8y. So now it's let's input the values. The coordinate is 12,4, right? The x and y. So dy by dx of tangent gives me x over 8y. X is 12 over 8 times y is 4. How much is it? 12 over 8 times 4. Can I know the simplified answer? 3 over 8. Okay, so then now let's get the equation of tangent. So equation of tangent, y minus y1 equal gradient x minus x1. Y minus y1 is 4, right? Gradient is 3 over 8. X minus x1 is 12. Is this okay? Then I'll take 8 to the other side. I'll multiply the whole thing with 8. 8y. 8 times 4 is 32, right? Here I'll open with 3. 3 times x is 3x. 3 times 12 is 36. Do you agree with me? So I end up getting 8y minus 3x minus 32 plus 36 is plus 4. So this is the equation of the tangent. Okay, similarly, I have to also get the equation of normal. So how do I get the equation of normal? The same thing, get the dy by dx of normal. When you get the gradient of the normal, basically what? Reciprocal and change the sign. Okay, reciprocal. When you want to get the gradient of normal, reciprocal and change the sign. Positive becomes negative. 3 over 8 becomes 8 over 3. Okay, gradient product is minus 1. That's what I'm using. So equation of normal is y minus y1 equals gradient x minus x1. Y minus y1 was 4, right? Gradient is minus 8 over 3. X minus x1 is 12. So take 3 to the other side. 3 times y, 3y minus 3 times 4, 12. Minus 8 times x minus 12, right? Yeah, we could open it immediately. Minus 8 times x is minus 8x. Minus 8 into minus 12 is plus 96. And then take everything to one side. 3y plus 8x minus 12 minus 96 is minus 108. Yeah, so that's it. That's the equation of your norm. Okay. Okay, so now the next one is, okay, now look at the next one. For part B, children, find the equation of tangents and normals to the hyperbolas with the following equation. Do you notice that in this format, that this is the format that I did all my proofs for? Okay, so the thing is this, all you need to do is to directly, the thing is in the exam, of course, you don't directly go with that. You have to do the proof and show. Okay, but so since I have done the proof, we just did it now, we'll use that and do this. Okay, you all did it from the beginning, like everything. Yeah. Okay, so I'm not going to do that to save time. I will use the shortcut. Okay, so what was the equation of the tangent? Can I know the equation of the tangent at the point A cos t? We found, so that normally if you have do like this, they would probably ask in part A to do that proof. The proof with it tangent at point, what was it, A cos t B sin. They would ask this for the first part. Okay, so can I know the equation of the tangent? What was it? The proof that we did earlier. The tangent at A cos t B sin t. The tangent at A cos t B sin is AY sin t. Tell me. AY sin t plus AB equals BX cos t. Am I correct? Is this okay? So now all I have to do is input the values of A and B because I have done the proof. Okay. So my A value is 5 and my B value is 2. So I input the AB value. So this will be A is 5, 5Y, it's sin t, right? AB is 5 into 2. B is 2x cos t. So I get 5y sin t plus 10 equal 2x cos t. Is the answer? Okay. Then the next one, normal equation. What was the normal? The arrangement can be anything because you could make y the subject, take x and y in one side. That's fine because they haven't given you any arrangement. You could keep it in any way. Okay, unless they strictly ask you to make y the subject, there's no problem. I just gave it in the format that they gave us. Okay, normal at point A cos t B sin t. Can someone tell me? Minus, no, the equation. The equation of the normal was x sin t plus b cos t equal a square plus b square. Okay, right, then let's input the values. A is 5, right, and b is 2. So 5x sin t, b is 2. A square plus b square is 5 square plus 2 square, which gives me 5x sin t 29 sin t cos t. Okay, then the next one, part B. Part B, this is second question, part A, right? Now second question, part B, it's x square over 1 minus y square over 9 equal 1. Okay, so you can see your A and B, right? Here again. So you can see even the AB, you could even take from the ellipse equation also. You can see A square 25, A is 5, B square 4, B is 2. You can take AB even from the ellipse equation because it follows. So A sec t, A is 1, B tan D, B is 3. You see, because B square is 9. This is x square, A square, Y square, B square. B is 9. So that B only comes here. Okay. So what was the equation of the tangent at point? What was the equation of tangent at point A sec theta, B tan theta? Yeah. Again, what is it? AB equals dx sec theta. So input the AB values. Your A value was 1, B value was 3, right? Okay, so input it. AB is 1 into 3, B is 3x sec theta minus 1 y tan theta. Okay, in the exam, you need to prove and use. You can't directly use. I did this because we did the proof. Okay, you must prove and do all these sums because you only get one sum in the exam. In that, you cannot like simply use a derived formula. You are not allowed that. You need to derive and use it. So we have to do it from the beginning because just because we derive it a moment ago only, I decided on using it. Okay, so we will do a few past paper questions also before we end the lesson. Then you can understand how these things are done. Okay, then the next one is can I know the tangent, the normal at point? Normal at point. A sec theta b tan theta. What was the format we used? By plus ax sine theta equals to a square plus b square tan theta. Then b is 3y, a is 1x sine theta, a square is 1 square, b square is 3 square tan theta. So I get 3y plus x sine theta. This is 3 square is 9 plus 1 is 10 tan theta. Do you agree with that? Okay, so is that correct? This is with t. It's with theta. Wait, what have I done wrong here? 3y. Okay, this is second question, part B. It's not theta. Or it's sec t. Right. In my in the equation, yeah, it's sec t 3 tan t. Yeah, so this should be in t. Yeah, the equation they had given us was in t. Is that correct? Dy sec t. Okay. Right, then shall we move on next part? Okay. Okay, so I'll do question number 8 now. The line y equal mx plus 12 is a tangent to the hyperbola x square over 49 minus y square over 25 equal 1 at the point P. Find the possible values of m. So there are two ways of doing this. What are the two ways? One way is where you actually attempt to solve the equation of the line with the equation of the hyperbola and actually what? Attempt to solve it simultaneously and end up getting a quadratic equation and you set the discriminant to 0 and you can find the m values, which is exactly what we did in the earlier section for the ellipses. Do you remember? Or the other one is where you use the shortcut. So this is the tangent and a hyperbola. So for the line y, so you can write the condition. The line, what was the condition? The line y equal mx plus c is a tangent to the hyperbola. What was the condition? When b square plus c square equal a square m square. Okay, so this is the condition. So if this condition is satisfied, it's a tangent. So according to our hyperbola, the a square value is 49. Do you see? B square value is 25. Can you see? So the a square value is 49. The b square value is 25 and the n value is unknown. C value is 12. C value is 12. Let's input b square is 25, c square, which is 12 square. A square is 49 times m square is what we are trying to find. 25 plus 12 square is 144, 49 m square. 25 plus 144 is 169 equals 49 m square. So this gives me m square is 169 divided by 49, which is, it's not divisible, right? So this gives me m is square root of 169 over 49, which is plus or minus 13 over 7, which is plus or minus 13 over 7. That's all you need. Okay, so there are so many questions here that you could try. Okay, so I will go on to question number 12. Let's try question number 12 now. Let's go to question number 12. The hyperbola h has equation x square over 49 minus y square over 25 equal 1. The line L1 is a tangent to the hyperbola at the point 7 sec theta, 5 tan theta. Use calculus to show that an equation of L1 is this. Okay. Now in this case, look, in this case, I'm not going to use any shortcuts. Why? They have asked us for 5 marks to do the whole proof. Can you see? So that means we need to do this, do the proof from scratch. Okay, no using shortcuts. You can't remember the equation and use it. Okay, right. So then let's get it done. Question number 12, part A. Get the equation of the hyperbola and you start by what? Differentiating it. Okay, x square over 49 minus y square over 25 equal 1. Let's differentiate. So 1 over 49 weight, x square differentiation is what? X square differentiation is 2x minus 1 over 25 times y square differentiation is 2y times dy by dx equals differentiation of 1 is 0. Okay, so then let's rearrange this. This is 2x over 49 equals this side I have 2y over 25 dy by dx. I could cancel out the 2 to 2 and I end up getting 25 over 49 x over y equals dy by dx. Is that okay? Okay, so then now let's get the equation of they want the tangent at the point 7 sec theta 5 tan theta, right? The tangent at the point 7 sec theta 5 tan theta. So the point is 7 sec theta 5 tan theta. So get dy by dx of tangent 25 over 49 times x is 7 sec theta over y is 5 tan theta. Okay, does it simplify? Yes, we can cut off, right? 7 times 1, 7 times 7, 5 times 1, 5 times 5. So I end up getting 5 sec theta okay, then let's see, I get the equation of the tangent. So the equation of tangent will be y minus y1 equal gradient times x minus x1. Y minus y1 is 5 tan theta. Gradient is 5 sec theta over 7 tan theta. X minus x1 is 7 sec theta. So this gives me, I'll multiply the 7 tan theta to the other side. Is it to show that? Show that, yeah. 7y sin theta equals 5x minus 35 cos. To show that. So I end up getting here 7y tan theta minus 7 times 5 is 35 tan square theta equal 5 sec theta into x is 5x sec theta minus 5 times 7 is 35 sec theta tan theta, sorry, sec square theta. Sec into sec is sec square. So, according to the show that, what do they have? 7y sine theta, okay, it's all sine and cos, right? So, I think the first one thing we could do is we could get rid of the 35 tan square, 35 sec square, because the rule is sec square minus tan square is 1, right? 1 plus tan square equals sec square is the equation, the identity you learn in P3. Derived out of sine square plus cos square equal 1. This gives us sec square minus tan square equals to 1. So that means what I'll do is I'll bring the 35 sec square here. So I have the 7y tan theta waiting here. 7y tan theta minus 35 sec square comes as plus 35 sec square minus 35 tan square equals to 5x sec theta. Is that okay? Now what I can take a 35 out. Taking 35 out, I get sec square minus tan square is 1. So 7y tan theta and then the show that had what was the show that? The show that had 7y sine theta, 35 cos theta. So basically, yeah, we'll multiply the whole equation with cos. So when we multiply, I get here 7y tan theta into cos theta plus 35 cos theta, 5x sec theta into cos theta, you know, it becomes 1. Sec into cos is 1. So tan is sine over cos, right? And I think you can see what's going on here. The cos to cos will cancel out. Okay, so I think, yeah, we got to show that, right? Do we need to rearrange? 7y sine theta is a subject. 7y sine theta, keeping it the subject, equals 5x minus 35 cos theta. Is that okay? So this is the derivation, the full proof for the 5 marks for the equation of the tangent. Okay. Then shall we move the next part? In the next part they say part B. This is so line one was a tangent. That's what we found. Use calculus to show that an equation of line. Okay, we did that. The line 2 passes through the origin and is perpendicular to line 1. Okay, now what's going on? Are they saying it's a normal? No, it's saying they say line 2 passes through what? It passes through the origin and is perpendicular to line 1. The lines L1 and L2 intersect at Q. Okay, before I move on to anything else, how do I find the equation of line 2? The first thing about line 2 is it is perpendicular to line 1. So if it's perpendicular to line 1, we can at least get the gradient, right? So gradient of line 2, how can I get it? Gradient of line 2, they basically reciprocal the gradient of line 1 and so switch the sign. So I have the gradient of line 1 here, 5 sec theta over 7 tan theta. This is the gradient we got, right? So basically what? Take the reciprocal. When you reciprocal and switch the sign, I get minus 7 tan theta over 5 sec theta because it's perpendicular. And they say this line 2 passes through what? Origin, means it passes through 0, 0. So then I can now get the equation of line 2, right? So equation of line 2, or we'll say equation of L2. Equation of L2, y minus y1 equal gradient x minus x1. So y minus y1 is now what? It passes through 0, 0. Gradient m is minus 7 tan theta over 5 sec theta. x minus x1 is 0. So I end up getting here y equals minus 7 tan theta x over 5 sec theta. Is that okay? So now let's see, this is the equation of line 2, okay? This is the equation of line 2. Okay, what do we need to do now? They are saying the lines 1 and line 2, the lines L1 and L2 intersect at the point Q. So they're asking show that the coordinates of the point Q are this. Okay, so what do we need to do here? Solve a pair of simultaneous equations and show that the intersecting point is actually this. Okay, shall we start that? Okay, so line 2 is there. Let's get line 1. What was the line 1 equation? The line 1 equation was 7y sine theta equals 5x minus. So then what's the easiest? I think you can see in this equation that I found for line 2, I have already made y the subject. All I need to do is take that y value and input it in the y value here. Okay, shall we input? So 7 and I'll keep the sine theta together. Is that okay? I'll keep 7 sine theta and input the y. Who is y? Minus 7 tan theta over 5 sec theta times x. Equals on the other side I have 5x. So what do we have here? Minus is minus 6 a minus 7 times 7 49 sine theta tan theta over 5 times sec theta holding x. Are you okay with this?
Minus 49 over 5.
Yeah, we can write minus 49 over 5 sine tan over sec. Yes, we can do that. Okay. So now what I'll do is I'll take this x term entire to the other side and take the 35 cos theta here. Is that okay? Because I want to make x the subject. So 35 cos theta comes here as a plus. Here I get 5x plus. Yeah, if you want, you could write 49 over 5. Yeah. Sine theta, can we fix this? Yeah. Sine theta tan theta over sec theta. You know, we could save some steps here. Okay. Yeah, you know, sec theta is 1 over cos, right? So this is sine theta. The sec comes up as what? Cos theta, and tan is actually what? Sine over cos. So then cos will actually cancel out. And this side you have 35 cos theta. So I have here 35 cos theta. Yes, 5x. This is plus 49 over 5 sine square theta. Yes, because there's a over 5. I'll multiply the whole thing with 5. What do we get here? 35 times 5 is 175 cos theta. 25x plus sine square. I think I forgot the x here, right? There's x here. Take x out. And I get 25 plus 49 sine square theta. Is that correct? Am I getting to show that? 175 cos theta, yes. Yes, so that is the show that. So get the answer. So I end up getting x equals 175 cos theta over 25 plus 49 sine square theta, which is our show that, right? The show that is the place where the line L1 and L2 intersect the x coordinate. You must also get what? The y coordinate. So how do you get the y coordinate? I think the substitute the easiest one. So there are two equations. L1 is easier than L2 because y is already subjected. So L1 y equation is what? Tell me the L1 equation. Y equals minus 7 over 5 sec theta times x. So now replace the x here. Minus 7 tan theta over 5 sec theta multiplied by the x is 175 cos theta over 25 plus 49 sin square theta. Okay, so I think we can simplify tan is sine over cos, right? Minus 7. Tan is, yeah, sine over cos. There's the 5 here. The sec we can bring it up as a cos. Sec we can bring it up as a cos. This is just basically rearranging. The sec went up here. Okay, the sec went up. Tan is sine over cos. Into 175 cos theta over 25 plus 49 sine square theta. So you can see here this time cos theta cancels off. Is that correct? I think 175 and 5 also we can simplify, which is 5 times 1 is 5, 5 times 35. 130. So then we can multiply minus 7 times 35 minus 245 sine theta cos theta over 25 plus 49 sine squared. This is the intersecting point. So I think this is to show that, right? They wanted us to get the place where the two lines meet, L1, L2. So x comma y. So is that to show that, yes, minus 245 sine cos over 25 plus 49 sine squared. So can you see? It's done. Okay. Right. So then we'll move to the next part now.